Our next speaker is Ismael Mariño. He's a researcher and professor at the Escuela Nacional de Estudios Superiores, which is the National School for Higher Education affiliated to UNAM in Mérida. He's a physical oceanographer, and he has been working during the last few years on multi-criteria assessment of ocean currents and energy production.
Thank you, Sharon. Thank you very much. Can you see my screen? Can you see the presentation?
Yes, it's perfect.
Excellent. Okay. I'm very pleased to be here talking to you about this topic. Thank you very much for inviting me. And today I would like to tell you a little bit about the possibility of using marine currents for the generation of energy in Mexico. Sorry, I'm just making sure you can see. Okay, so, and I will focus on the assessment of the resource and also on some environmental considerations. I really believe that humans need to change the way in which we obtain energy and use it. At the moment, the use of energy per capita in the world will only increase, and 80% of that is generated with fossil fuels. So if we continue with business as usual, this implies that climate change consequences will be worse, compromising seriously the environmental stability that supports the existence of our economies and societies. So we really need to work on thinking forward on different ways of getting energy, and renewables are one possibility. Within all the scope of the renewable energies, we have currents which are driven by different forces, and the gravitational attraction of sun and moon generate tides, and with tides, these changes in surface elevation of the ocean, there's also currents. These tidal currents are attractive for the generation of electricity because they are highly predictable. So you can actually calculate when you can count on with this energy supply, which is not the case for most of our renewables. And also, in some parts of the world, not everywhere, but mainly, for example, on the North Atlantic, in Europe, around Scotland and the North Atlantic, you can find very, very intense, about 5 meters per second currents. Just for reference, one Olympic swimmer will be swimming at 1 meter per second. So these are really strong currents. And this makes tidal currents very attractive, and it's already being used in the world for generation of energy. So what about tidal currents in Mexico? This is a map that shows you that most of the tidal current energy is in the upper Gulf of California. And in there, assessments made by one of the collaborators in the project, Dr. Vanessa Magar from CICESE, shows that there are regions, like these regions in yellow, where the accumulated annual energy production would be about 500 kilowatt hour per meter square, more or less. This is here and here. So despite there is some regions where this is possible, this needs to be assessed for environmental concerns because the region has a very sensitive marine environment. Other type of currents that are becoming really important for or more attractive for the generation of electricity are those currents of western boundaries of the oceans, like, for example, the Kuroshio current or the Yucatan current and the Gulf Stream, the Brazil current, amongst others. Why is this? Well, these currents have a very wide transverse sections. They are relatively close to continents, so the connection to the grid is easier, and they can be very persistent and fairly intense. I mean, they can go above 1 meter per second, but they never reach the 5 meter per second of tidal currents, for example. An assessment in Mexico shows that this map that I'm showing you shows you the percentage of time that you have currents above 1 meter per second, And clearly, the Mexican Caribbean, the northern Mexican Caribbean, is the place where this occurs and is most attractive. So assessments in this region with numerical modeling adjusted with local measurements show that we do have energy in the mainstream which can be of use. This is about 7 megawatts. So we want to compare this with the tidal estimations that I've shown you before. So what I'm going to do is to homogenize the energy range and adapt the spatial scale. You can see that in the Mexican Caribbean we have much more than what we have in the higher Gulf of California. Although what we have in the Gulf of California could be of use. So the problem with this is that most of the energy is, as I've shown you before, in the deeper part of the channel. This is 400 meters, which is logistically very difficult to use, right? So what we've been finding through other partners in the project, like ECOSUR, places closer to the shore, like at 20 meters depth, where this can still be attractive. And this has been corroborated with measurements where we can find about 1 megawatt hour per meter square in regions which are closer to shore, which makes it easier operationally. Okay, the thing is, if we really want to make renewable energy feasible for the future, we need to guarantee environmental integrity. So this must be included. And Marisa will talk to you more about this. But I'm going to show you some of the assessments we have made for the Caribbean region using the approach of Pacific Northwest, where the effects of the turbines could be direct, as a direct collision with the turbines, or through noise that can affect the organisms, or indirect through changes in the flow, which will change the habitat. And some examples of these will be the disruptions in Laravel Dispersion, alterations in hydrosedimentary processes, which can change coastal ecosystems and benthos, and changes on oceanographic conditions like temperature and mixing. This is the example for noise propagation. So we used a numerical model called ACTOP to model the propagation of noise of 800 turbines, which is the amount we are at the moment pushing forward as a probably good option in the region that I've shown you, the northern part of the Cozumel Channel. So these 800 turbines will be producing, according to this model, this amount of noise in the Yucatan, in the Cozumel Channel. The red values are low values of noise, and the blue is stronger noise. Just to let you know, the ear damage threshold is about 174 decibels. So we don't really reach that, not for the 10 hertz pitch or noise, or higher pitch like 75 hertz. We don't reach a near damage threshold. And also, this needs to be evaluated in the context of the existing noise in the place. The place is heavily used for tourism, so there is a fair amount of noise of jet skis and boats, etc. We have also analyzed the changes in Laravel dispersion using this numerical model, the ICTIOP. In the panels above, I'm showing you the dispersions of coral larvae from the Cozumel reefs, which are in the south. And the square here is where the turbines could be installed. And the difference in the dispersion patterns without the turbines, which is above, and with the turbines, which is below, is really very, very small. So we think that the placement of 800 turbines, this is 5 meters diameter more or less, would be something feasible. On the same idea, the turbines will be here. Is these lines that you can see here. The wave propagation is not very affected by this amount of turbines, and therefore the effects of coastal habitats and benthos, we will expect that it will be small as well, because wave propagation could be a good indicator of coastal change. Finally, if we are not careful with the amount of turbines we use, we could induce some very large changes. And this is some work made by Dr. Aljas Maslow, a postdoc in the project running the ROMS model. And what you can see here is the temperature differences of filling the channel with 5,300 turbines of 30 meters diameter, that's really large. And this amount of use of the Yucatan Channel will induce drastic changes in temperatures. Like, for example, you can get up to 4 degrees centigrade closer to shore, where all the reefs are. So this is not good news for the corals. But also, you can see here that these turbines can induce a stronger upwelling events. So this is what happens with this amount of turbines. So just to finish up, I'll tell you that we think that oceanic currents in the Mexican Caribbean have a good potential for electricity generation, background electricity generation, because there's not large amounts of it, but we can get some of that. These 800 turbines will be producing about 10% of the energy in Cozumel. These are the estimates that we have. But we do need technology that is better suited for low velocities. As I'm showing you, the velocities that we have, despite we find it strong, like 1 or 2 meters per second is a strong current, but they are not very strong related to what is developed already for tidal. So that's why Edgar's work is really important on developing these new turbines. We need to avoid environmental effects, so it's crucial to design turbine fields with numerical modeling to try to avoid these drastic changes. And in general, tidal energy is scarce in Mexico, but the upper Gulf of California can provide some energy, but we really need to do some environmental assessments there, which is very important. And this is all. Thank you very much.
Thank you very much, Ismael, for that very interesting presentation. Our next speaker is